Well, hello there. Have you ever heard the word crypto being used before? That is coded messages to hide packets of information away from prying eyes of those that we do not want to be able to see or access this information. Now, crypto is used in a lot of different areas. You might have heard cryptocurrencies before, but also we use encryptions for things like credit cards and passwords and a whole range of stuff all over the internet. In today's task, we're going to have a look at how crypto or cryptography is actually used to code messages, and your students are going to explore this through a rich and open-ended investigation. Now, before we get started, you're going to need to get a few resources that you can prepare and get ready to use with your class. The first is to download and print out the CryptoShifts sets that you can see here. Generally around about one set per 5 students is the way to go. Once you've printed them out, make sure you laminate them so that students can write all over them with whiteboard markers and then rub them out once they're done. Now, of course, if they're going to do that, they're also going to need a whiteboard marker each and also a little mini eraser or even some whiteboard cleaner as well, just to help get off whatever they've written on the laminated sheets. Now, this video is broken up into 3 sections. The first is the engage section, where we get students to have a go at a bit of the task and just whet their appetite for cryptography and start to want to explore it more. The next section is all about the main activity and getting students to extend themselves and think about the mathematics in a deeper level. And the last section is called the spoiler alerts, so that you as a teacher can know, all right, how might we go about actually addressing this task or doing this task with the students? Some things to look out for. And of course, you probably want to have some idea of where the task ends up going, which we'll talk about in the final section. So let's now have a look at the engage part of the lesson. The purpose of the engage phase of the lesson is to get students thinking about the maths and wanting to explore it more. So this is how I introduce the CryptoShifts mathematics task when working with my students. Now, did you know that not all alphabets contain 26 letters like what we use when we speak and write in English? In fact, the Khmer alphabet is the largest alphabet and it's used by the Cambodian people, and it contains 74 letters or symbols in order to be able to write in their language. And the smallest alphabet is the Rotokis alphabet, used in parts of Papua New Guinea, and it contains only 12 letters. Imagine for a second that we made an even smaller alphabet and we had only 8 letters like what you can see here. What words could you write in English using just these 8 letters? What's the biggest word you could write? And also maybe what's the smallest word you could write? And how many different words can you come up with? I'll let you have a play around with that and see what you come up with. Now, the main activity and the extension part that can go with it explores different ciphers that you can apply to different size alphabets and see what works, but also what doesn't. So I'm going to show you now how you can go through and build this understanding with your students. Now, for the main activity, you're going to need these sheets here. Those are the CryptoShifts sheets, all printed out and laminated, ready to go, so that students can write on them and then rub out what they've done once they've written on them, because there's going to be a whole lot of writing out and then starting off with a new problem or a new version of the task and keep going on with that. So they will need to be laminated. All right, and we're going to actually start off with the 8 size alphabet, like the one I introduced to you in the engage section of this video. And the reason for that is because it starts off with a nice, easy number to be able to look at and explore, and then students can explore other size alphabets once they get the hang of it. So let's have a bit of a look at this. You may have realized when you went through and explored in the engage section that one of the words that you could come up with was cabbage. So I'll use that as an example, cabbage. And we're going to apply a cipher to be able to code this word cabbage. And the cipher that we're going to use to start off with is multiplying by 3. So that is, we're going to multiply every position by 3 and move it to the new position. So what you'll see here is you've got A and it's in position 1. So we're going to use this number here, the position, and multiply it by 3. So that takes it to its 3rd position. So we look at the 3rd position and I would write A here. Now B is in the 2nd position. So I look at 2 and I multiply 2 by 3, taking it to 6. So B is going to go to the 6th position. and you'll see that I'll write B here. C, being 3, multiply that by 3, takes it to the 9th position. Now let's have a think about that for a second. I've got 8 positions here, and if I continue around, it means that this here would be the 9th position. So C is in fact going to go where it says 1, but it's the 9th position when you continue to go around over and over again. D, well, 4 multiplied by 3 is 12. And if we know that all the way around to here is 8, 9, 10, 11, 12. So therefore, D will go to there. E, 5 multiplied by 3 would be 15. Now, if I think about that, around to here would be 8, and then around again would be 16. So therefore, the 15th position would in fact be here, and I'd write E there. F, 6 multiplied by 3 would be 18. So if I think about it once again, I could go, all right, 8, 16, 17, 18. So therefore, I would write F here. G, well, 7 multiplied by 3 is 21. If we think about it, 18th position was there, 19, 20, 21. So I could just do that there, couldn't I? And then finally, H multiplied by 3, or 8 multiplied by 3, would be 24. And we know that if we go 8, 16, 24. So H also stays where it is. Now let's figure out what it is that's going to go in, how we're going to code this word and swap the letters around so that it doesn't actually read cabbage anymore without having the cipher. So let's have a look at that. We're going to go with anywhere where there's a C, we're now going to write an A. So you can see here, C is going to be swapped over for an A. The letter A, well, where's A? A is going to be swapped over for a C. Oh, there's another A here, so I'll just write that there. B is going to be swapped over for an F. G was here, and it's going to be swapped over for an E. And E was here, be swapped over for a G. So you would write cabbage after applying the cipher like this. All right, well, that's all great, but what happens if I maybe change the cipher? That is what I'm going to multiply by, all right, the key. So if I come here, I'm going to rub that out, and I'll rub out all these positions, and I'll do the same thing again, but this time I'm going to multiply everything by, let's say, 4, all right, and we'll see what happens. So if I go 1 multiplied by 4, well, that gets me to the 4th position. So A will go to the 4th. B, 2 multiplied by 4 will go to the 8th, so I'm going to write it over here. So B would go here. C, 3 multiplied by 4 would be 12. Well, if that's the 8th, 9, 10, 11, 12. Oh, wait a second. C also is here. D multiplied by 4 would be 16, so that means D would go here. E multiplied by 4 would be 20, 16, 17, 18, 19, 20. E would go here as well. F multiplied by 4 would be 24. F, and in fact, what's going to happen is I'm going to get G here and H here. Now, as you can see here, I've got many different letters being represented by the same letter. So if you think about that, anywhere where I see a C now, well, that's going to be a D. Anywhere where I see an A will also be a D. So when it comes to trying to actually cipher and figure out what these are, you won't be able to do that because you've got more than one letter being represented by the same letter. So therefore, we can't actually apply that cipher. That is, this cipher of multiplied by 4 won't work. So your challenge as crypto kings would be to go through and figure out, well, what ciphers or what multiplication keys will in fact work with different size alphabets. All right, we know 3 does for 8, but we know 4 doesn't. Are there other ones that do and don't work for different size alphabets? All right, best of luck. So let's now have a look at the spoilers part of this video. That is where I show you different strategies that you can use to help students to collate their thinking and identify mathematical patterns. But also we'll have a look at the different solutions and ideas which should come to light when you go through and do the CryptoShifts task. So let's check it out. Now, the biggest helpful hint or spoiler that I could probably give in terms of attempting this task is that in order to be successful, students are going to need to come up with a way in order to represent all of their findings or keep track of all their findings so that they can identify patterns and start to make conjectures in what they do. Now, this won't automatically become evident to students, and I recommend not saying anything to them and letting them discover this for themselves. For example, as you go around the room, you might notice that students start to do a bit of this, where they'll find some where it works for a number, but then what they'll do is once they've got a solution, they might even just rub off everything and not even keep track of it and forget what they've done and what they haven't done. It won't be long before students then realise, well, wait a second, I've forgotten what the result was when I did apply a cipher of 4 for 9 and then have to go back and do it. And if they have to keep doing the same things over and over again, they'll start to realise, oh, I've got to keep track of it somehow. So you might see students just doing this, and that's fine. I recommend leaving it for a little bit. They'll figure out that they need to keep track of their results somehow when they have to go back and repeat it. But as you walk around as well, it's worth keeping an eye out for students who are or who have come up with ways to keep track of their results. So what I've seen in the past is something like this. So you can see here that there's different ones where kids have written down, ciphers that work and ciphers that don't. Quite often what I find though is students just write the ones that work and forget to write down the ones that don't. And that once again gets in the way of them actually being able to figure out everything that's going on, because they forget, well, have I actually tried this one? Or did it not work if I didn't write it down? So keep an eye out for it. And if you see students who are writing down ones that work and ones that don't, both of them, then get them to share their strategy with other students in the class, because this is really going to help everyone to move forwards in their thinking. The other thing is when you go through and do this task, you'll notice there's a lot to explore here. And in fact, there's so much that one person exploring it on their own will take a long time to do it. So it always works better when you've got students working on different size alphabets with different ciphers and things like that. So for example, you might have a group of 5 students and every student is responsible for maybe one page. So one student might be responsible for looking at ciphers with 13, 14, another student with 7 and 8, etc. But don't tell them once again, let them go through and do that. And then naturally they'll start to share their thinking and their ideas. Of course, if they don't do this after 10, 15 minutes, then as a teacher, you might want to prompt people towards this, but initially let them go through, play with the idea for themselves and see what they come up with, and see if automatically they start to come up with these ideas to keep track of their work and also to make life easier on themselves by collaborating with each other. So that's the first little helpful hint that I'll give. The next one is once you've seen students start to do a bit of this, then it's worth actually saying, well, how can we keep track of this as a whole class? What can we do to make sure that we can all have a look at what's coming up and then use all of the information that everyone's exploring to be able to figure out, well, what is the actual pattern going on? And that's where you might want to create something like what you've got here. That is, you've got a table with an alphabet size and you write down all the alphabet sizes that we've got on those CryptoShifts sheets, and then the ciphers which work and the ciphers which don't. And as students go through and complete it, or any results that they've already got, they can come up and write on the class board all the different results which come to light. Now through doing this, you'll see here that there's going to be an image pop up on the screen. Now when you look at this table, you might start to recognize some patterns. For example, when I have a look at it, I can see that cipher of 1 doesn't ever work. All right, and the reason for that is because if you multiply everything by 1, like you can see here, well, the first one will go to the first spot, so A would be there. The second one will go to the second spot, so that would be B. C will go to the third spot, D, E, F. So if you apply this cipher, that in fact will never work, because you'll see that it's always going to be the same letters representing the same things, and therefore it's not going to be a coded message anymore. So that cipher itself, even though everything fits in a place, it doesn't actually work. And the same thing applies for if you see a cipher where it's a multiple plus 1. So for example, for 13, if I wanted to know if it worked, well, I might try 27, for example. So multiplying everyone by 27, let's have a look at what happens. I'll just rub this out. And let's multiply everything by 27. So 1 by 27 will go to the 27th position, which of course will be 13, 26, 27. Okay, so A will go there. B will go 27 times 2 would be 54. Okay, well that'd be 13, 26, double it again, which would be 52, and then 2 more, B will go there. C times 27, well that'd be 81, wouldn't it? Well, in fact, it's going to be the same thing again, wouldn't it? Because you can see here it'd be 13, 26, plus another 13 is 39, 52, 65, 78, 79, 80, 81. And if the cipher is a multiple of the alphabet number plus 1, for example, 13 times 2 plus 1 being 27, it won't actually work because it will give us the same thing as what it will do when we have a cipher of 1. And the last spoiler in terms of looking through and figuring out answers that you'll see is that anyone where the cipher and the alphabet number share a factor, it won't work. So what I mean by that is in order for it to work, the alphabet number and the cipher need to be co-prime. That is, they have no other common factors than 1. So for example, if you have a look at the alphabet size of 5 and the cipher of 2, there's no common factors other than 1. The same for alphabet size of 5 and 4, or 5 and 8. Alright, same with if I have an alphabet factor or an alphabet size of 11, you'll have a look with the ciphers at work. All of those only have a common factor of 1 with 11. Whereas when you go through and have a look at 12, the ones that don't work, the 2, the 3, the 4, the 6, and the 8, either are a factor of 12 or they share a factor other than 1 with 12. So therefore, the ones that do work are co-primes because they only have the one factor in common with the alphabet size, and that is 1. So in summary, for a cipher to work, it cannot be 1. It also cannot be a multiple of the alphabet size plus 1, because in both of those instances, there's no shift in the actual letters. And also, it must be a co-prime with the alphabet size. That is, the cipher and the alphabet size cannot share a factor other than 1. So there you have it. That there was a CryptoShifts lesson. If you do decide to have a bit of a play around with it and trial it with your class, please feel free to give us some feedback on how it goes.